right, so today we're going to move on to what is called the law of cosines. The law of cosines you're going to use when you have SAS or side, side, side. Remember, SAS is side, angle, side, and so that's when you have a side, an angle, and another. You have the two sides and the angle that is included, or the angle that is in between them. Okay, so let me just show you what laws of cosines looks like. And this is kind of an easy way to help you remember or get it memorized as well. So the law of cosines is, so first you can take a squared, okay, and set it equal to, it's b squared plus c squared. So again, I know b and c. I'm going to subtract 2 times bc times the cosine of angle A. By the way, this is derived from Pythagorean theorem, okay? You could also find b squared, and so watch how I kind of remember how this works. So b squared is going to be a squared plus c squared minus 2ac times the cosine of angle B, okay? Or you can do c squared equals a squared plus b squared minus 2ab times the cosine of angle C. Okay? All right, let's go do a couple of examples and see how it works. All right, so let's go try a couple of examples. So the first one, I have a side, I have an angle, and I have another side. And so I'm going to go find what this side over here is. So it really doesn't matter, to be honest with you, which one you call A, B, or C. If it makes you feel better, go ahead and label them, okay? But I do know that x squared is going to equal my 23 squared plus 9 squared minus 2 times 23 times 9 times the cosine of whatever 71 is. So it's just a matter of typing some things into my calculator, okay? And so I end up with, let's see, 23 squared is 529. 9 squared is 81. 2 times 23 times 9 is 414 times the cosine of 71. Okay, and I'm just doing a little bit of math, trying to get this figured out. 414 times the cosine of 71 degrees is going to be 134.785, it looks like. And I just used the answer button on my calculator, so I didn't have to worry about rounding. I didn't have to worry about, any of that sort of thing. But I end up with x squared to equal 475.2. And I don't know about you, but that doesn't make a lot of sense. If I'm looking at a side that's 23, 9, the other side is not going to be 475. So I'm just going to square root that side, and I end up with 21.8 if I round to the nearest 10. Okay, so again, x squared equals this, so x is going to equal 21.8. Go ahead and try example number 2, see if you get the same answer that I do. All right, so I just did it again. I plugged in some numbers, did a little bit of math. I used, if you notice on my calculator, I used the answer a lot so that I wouldn't have to worry about rounding my numbers. I goofed and put a minus sign or a plus sign originally, even though it should have been a minus sign. Part of the reasons why I write everything out and I do as much as I do is that because I make a mistake a lot. You know how many mistakes I make every day, right? I can't add. And so by writing things down, by writing out your numbers, it's easier to find your mistakes, okay? Example number 3, it says in triangle ABC, so you may have to draw a triangle. All right, so I drew my triangle. I even tried to draw it to scale, and so I have an obtuse angle at angle B, so I made angle ABC obtuse. I put my information in. Let's go do the laws of cosines and see what we get. Okay, so I know that side AC squared, okay, I labeled it as x over here. But I know that x squared is going to equal 10 squared plus 7 squared minus 2 times 10 and 7 times the cosine of 106. So I know this is going to be 149 minus 140 times the cosine of 106. Might want to double check my math. You know how I am. I can't do the simple stuff anymore. And whoa, check this out. Something a little weird ended up happening. But I got, when I did 140 times the cosine of 106, a negative number. So before I write this down, I want to see if that makes sense. Okay, so where is 106 degrees on the unit circle? Well, if I think about it, on the unit circle, 106 is past 90. It's in quadrant number 2. And the x value over there is negative. So this does make sense, and this is correct. So it is a negative 38.589 or whatever. Okay, so I end up with AC squared equaling 149. I'm going to have to subtract that answer in my calculator. 187.589 and square root that to get that side AC is about 13.7. Okay? All right, what if you have to find the angles? How does this work? All right, so let's go find this missing angle. And so this is going to be a little bit different. Keep in mind, though, that where this angle is, this is a side angle side. The laws of cosines works for that. And so when you go to set it up, the 11, the 10, and the cosine of x should all go together. So we're going to do 8 squared equals, okay? So I have 11 squared plus 10 squared minus 2 times 11 times 10 times the cosine of I don't know, okay? So here we go. 8 squared is 64. 11 squared is 121 plus 100 makes 221 minus, what is this, 220 times the cosine of x. Let's do a little bit of algebra. So I'm going to subtract 221 from both sides. I'm going to get negative 157 equals negative 220 cosine x. I'm going to divide by the negative 220. Make sure you're using your negative sign, not the minus sign when you do that. So I know that the cosine of my angle is around 0.7136. So I'm going to inverse that answer to find the angle. And it looks like angle X is 44.5 degrees if I round to the nearest 10. Okay? All right, let's go see what's on the other side. All right, so number 5, I'm just going to get it set up for you. Number 6, I'm going to go ahead and get set up for you. I want you to pause your screen and go ahead and try these problems on your own. Keep in mind with number 5, one more time, these are the numbers that are all going to go together on the one side of the equal sign. So in your laws of cosines formula, if I write that down up here, by the way, the more you write it, the more likely you are to remember it. The 13x and 5, this is all going to go over here together. The 16 is the one that's going to go by itself. Okay, so you're going to do 16 squared equals 13 squared plus 5 squared minus 2 times 13 and 5. And again, if you end up missing something by writing it all down, it's a little bit easier to be able to say, hey, this should have been equal to a 16 squared. That's what you missed, okay? All right, go ahead and pause your screen, and you can check number 5 and 6 in a minute. All right, so I'm hoping that you got the correct answers. If you did the math correct, you did the algebra correct, you should have ended up with for number 5, angle A, and I noticed I used an A instead of an X to match the picture. I used an A to match the formula. See what I mean by making mistakes, right? It happens to all of us. So you end up getting 118.5. Again, I'm hoping that it makes sense. The cosine was negative. The cosine should be negative over there in quadrant number 2. If you take a look at number 6, you had to draw the picture to get it to work. Notice how I put this little like mark right here. I knew that I had side angle side, so I knew that my 20 goes first. So I put 20 squared equals, and then the 25, 24, and the angle all go together. So when you do a little bit of algebra, do a little bit of math, you should end up getting 48.1 degrees, okay? All right, and so with the laws of cosines, this gives you a great opportunity to do a little bit of algebra, a little bit of math and trig to find some distances and things that you might need to know if you were, say, a land surveyor, okay? So let's take a look at number 7. Number 7, you're going to have to draw your own pictures. But we have basically Maple Street, Oak Drive, and West Avenue intersecting to form a triangular piece of land. And so I, drew a triangle first, and then I was like, oh, this is Maple Street, here's Oak, and here's West Avenue. And then I labeled my picture accordingly. Then for number 8, we have Jack and Tom, which, by the way, I changed his name to Tim in the picture because we have a Jack and Tim in class. They started a tree and they start running. I love my little running stick figure dudes, but Tim is over here flexing apparently because I drew his arm the wrong way. But they start going. There's a 23-degree angle between them. Jack is running a little farther than Tim is running, but I want to know what this distance is over here. So in a couple of minutes, I'm going to pause the screen and show you what the answers are, but I wanted to talk to you about number 9 because sometimes the picture is a little bit difficult. And can be a little weird. So just start drawing a picture and see what happens, okay? So number 9 says that we have 2 radar stations that are 2.5 miles apart and they're tracking an airplane, okay? So I have no idea what a radar station looks like. I'm just going to draw like this weird looking tower thing, okay? But I know that they are 2.5 miles apart and there's some kind of airplane in the sky. Okay, let's see. The straight line distance between station A is 7 miles. So I'm just going to call this station A and 7. Okay. The straight line distance between station B and the plane is 9 miles. So here's station B. Oh, and that is 9 miles. So it's almost like time is standing still with the plane, in the air. What is the angle of elevation? Angle of elevation. Ooh, how does that work again? From station B to the plane. Well, if I make this a triangle, I know that this distance down here is 2.5. Wow, that is so not drawn to scale. That's great. But angle of elevation from station B to the plane. So angle of elevation goes from a horizon and goes up. And so look at that. It's just this angle right in here that we're trying to find. Okay, so number 7, 8, and 9, go do laws of cosines and see if you can figure out what the missing piece of information is.
I'm sorry.
All right, so go double check your answers. Let's make sure that you got your answers correct. Okay, and so it looks like the length of West Avenue, according to the directions, nearest 10th angle is nearest degree, and so I got 421.2, which with these numbers makes a little bit of sense. Jack and Tim should be about 21.1 meters apart. Again, with these numbers, it should make a little bit of sense. At least I'm not ending with 446. Okay, that's what I mean by that. And then number 9, thankfully, some of my negatives ended up canceling out, and I ended up with a positive, which gave me a 32-degree angle of elevation from station B to the plane. Okay, so I just went over a couple of things with you. Your job is to go try some on your own. There's going to be some triangles, a couple of different word problems to try. Just do the best that you can. Okay, that's all I ask.